your system will be ENJ. ENJ means that total energy depends upon principal quantum number and total angular momentum. So that term will contain unperturbed term E naught. Then you will have kinetic energy correction. Then you will have your spin orbit correction. And finally, you have Darwin correction. ED means Darwin correction. So if you summarize all this term, if you write that ground energy of your system in terms of fine structure constant, so you will get the total energy of your system will be ME C square by 2, then Z alpha square by N square minus ME C square by 2 Z alpha e power 4 divided by N ki power 4 into N divided by J plus half minus 3 by 4. So this is the summary of all correction. Okay, so you can clearly see that total energy depends upon N and J. Okay, now I'll draw that plot for a 2 level, N equals to 1 and N equals to 2, and we'll see that how that kinetic energy, spin orbit correction, Darwin correction look like. Okay, so I'll draw that plot. So let us assume this is your N equals to lower level corresponds to N equals to 1 and upper level corresponds to N equals to 2. So obviously lower level will contain only S orbit because L is nothing but N minus 1. So here N is 1, so it will only contain S orbital. But for this case, you will get P orbital as well as S orbital. So after kinetic energy correction, there will be downward shift of your energy level, right? That we have discussed. So here also for S orbital, how much downward shift for N equals to 1? Of course, that downward shift will be less here because that depends upon 1 by N cube. Okay. So similarly, another factor, another P orbital will be there, but that shift will be less as compared to S shift. Okay. So this is after your kinetic energy correction. So this corresponds to your P orbit and this is your S orbit. Okay. So now after spin orbit correction, there will be no change in S orbital energy, but there is a change in P orbit energy. Okay. And this will be like this only. Now, so this up to this, let me rewrite. So up to this is your Bohr energy, right? This is kinetic energy correction. This shift is due to kinetic energy correction. Then this splitting corresponds to your spin orbit correction. Okay. So obviously this state will be what? 2p 3 by 2. Then this state will be 2p half. And this state corresponds to 2s half. Okay. And also this state corresponds to 2s half. Now there is a downward, there is a Darwin correction, right? So Darwin correction basically apply to S orbital only. And if you notice, yesterday we have discussed the downward that S orbital, there is a positive energy correction. So due to Darwin correction, this energy level will be flipped upwards, and of course this also, this level also, because this and these are S level, right? So after Darwin correction, what will happen? There will be no change in P orbital energy. It will be as like this. But after Darwin correction, this 2s half will be merged with 2p half. And that lower level S 2s half, there will be upward shift. So at the end, what you will get? This is due to your Darwin correction. Okay.
सर क्लास अभी स्टार्ट हुई है क्या?
अभी start हुई class.
ओके ओके सर.
So this is all correction. Bohr, first Bohr model, kinetic energy, downward shift, spin orbit correction only applied to that L equals to non-zero. So there will be splitting of P, but there will not be any splitting of S. But Darwin term, due to Darwin term, there will be positive shift of S orbital, but there will be no change in P orbital. Okay, so this corresponds to 2P, 3/2. This corresponds to 2P half as well as 2S half. And this corresponds to your 2S half. Here 2 means this is multiplicity, not this is like a principal quantum number. Okay, so you can clearly see this state are degenerate state, right? 2P half and 2S half, these are degenerate state, right? So
Yes sir.
but when a Lamb perform experiment, what he has noticed, there is a shifting between these two levels. So when he performed that experiment, what he observed, there is a splitting between 2S half and 2P half. So there is a that 2S half lie on the upward level, 2S half, here you have 2P half. And that separation he has noticed, that is around 4.3 into 10 to the power minus 6 electron volt. Again, the description of this. Yeah, that we'll discuss. Again, the description of this splitting belongs to your quantum electrodynamics. Now I'll explain this thing. So is this thing clear to all? So due to Darwin correction, there will be positive shift of S orbital, and S and P orbital will be merged. But when Lamb performed that experiment, what he noticed, that S orbital lie above the P to 2P half. So there is a splitting. That splitting is around 4.3 into 10 to the power minus 6 electron volt. Okay. Now that again that description or details analysis of this phenomena belongs to quantum electrodynamics. So I'll discuss this. Shall I erase this part? Is this clear to all? Is this clear
Yes, sir.
to all? Okay.
Sir, एक minute. Okay.
Okay. Now yesterday I told you, if you remove everything from your chamber, nothing is there, but you have half h cat omega energy, photon energy, right? You flash out everything, but still there is half h cat omega energy of photon, and photon is electromagnetic wave. And when that electromagnetic wave is there, nothing is there but half h cat omega energy of electromagnetic wave is there. So that electromagnetic wave will oscillate that electron, that orbiting electron. So suppose you have okay, so Lamb shift, that shift again I am writing. Sorry, 2P half, and that separation is 4.3 10 to the power minus 6 U. Okay, so suppose you have chamber, or let me write inside chamber, nothing is there, but you have energy, photon energy. That photon basically at any
h cat omega by 2.
that energy half h cat omega by 2 is present. Now you see, you have nucleus and electron, first orbiting electron located near to your nucleus, right? Then you have also p orbital electron also here, and you have many orbital orbit is there. now nothing is there, but you have some electromagnetic wave is present here, right? So when electromagnetic wave is there, of course that charge particle will oscillate, right? Under electromagnetic wave, charge particle will try to oscillate, right? Right. So what will happen? This charge, that orbiting electron, although nothing is there, but due to this quantization of EM wave, this half h cat omega will oscillate this electron. So electron will not like a point particle here. It will behave like a object having some radius. And of course, this is not true for s orbital. This is true for p orbital and higher orbital also. Is this concept clear? So under the action of electromagnetic wave, the charge particle will oscillate. So here that s orbital electron will oscillate, and that oscillation will be like this. So it will no longer be a point particle, but it will be an object having some finite radius. Okay, and same thing true for p orbital and higher orbital also. But you see, if you plot that potential energy curve as a function of distance, how it will look like? So suppose this is your nucleus, and along this x-axis, the separation or distance from nucleus, and that potential is look like this. And s orbital, yes
सर एक बार प्लीज ये फिर से बता दीजिएगा, आवाज आपका कट गया था सर इधर से।
कौन सी चीज बताना
सर ये आर के रिस्पेक्ट में आपने अभी क्या ड्रॉ किया है, बस थोड़ा सा बता दीजिए।
दिस इज योर न्यूक्लियस and potential energy from the center of the nucleus at some distance, or you can say that potential energy versus distance plot is look like this.
Okay sir.
Now s orbital is locating somewhere here. This is your location of s orbital. Here you have p orbital. Now you see, this is the potential energy. Along y-axis you have potential energy. This axis you have distance. Now you see, s orbital is very much sensitive to distance. If you change little distance, there will be huge amount of change in potential energy. But this is not true for p orbital. If you change distance, there will be no change in potential energy. Is this concept clear? So when that s orbiting electron is oscillating, that separation is getting changed. And if the separation is getting changed, there is a huge effect in potential energy. But same thing, proton is oscillating, its distance is getting changed, but potential will not be effect, because here potential energy is almost independent on that separation R. So that's why, due to change in potential energy in s orbital, there will be definitely change in energy. Is this concept clear what I'm saying?
Yes sir.
So that's why there will be modification of energy of s orbital. Okay, so that's why there is a shift in s orbital. I'm not going in detail, but basic mechanism, what it is a basic mechanism that I told you. So that s orbital is very much sensitive to distance, and that distance is getting changed due to that quantization of EM wave, and that's why there is a modification of energy of s orbital. Due to this, it will shift upwards. Okay, is it clear?
Yes sir.
सर एस अपवर्ड क्यों गया, पी नहीं, पी क्यों नहीं गया?
वही तो बोल रहा हूँ ना, क्योंकि पी का देखो, पी का एनर्जी का कोई चेंज नहीं है यहाँ पे, बट एस का जो है पोटेंशियल एनर्जी का चेंज हो गया ना. देयर इज अ चेंज इन पोटेंशियल एनर्जी, that's why there is a shift in energy. Of course, if there is a change in potential energy here, so there will be change in total energy of s orbital. So s and p orbital will no longer be degenerate now. S and p orbital will no longer be degenerate, because the potential energy of s orbital is now getting changed due to that finite radius of s orbital, s orbiting electron. Since there is a change in potential energy, of course there will be change in total energy. So there will be some finite separation between s and p, or 2s half and 2p half. Okay, and details calculation is belongs to quantum electrodynamics. So when we will do in advance, quantum electrodynamics. That time you will do that calculation. Is it okay? Is it clear?
Yes,
Yes.
sir.
Okay. So now today's the topic is really important for your exam purpose, because at least one question you will get from G-man effect or percent back effect. Okay. So I think sir told you that theory part of Zeeman effect. I'll touch little bit, then I'll do problem. Okay. So in first class we'll do some theory, and next class we'll do few important problem, and I'll tell you that shortcut also. Okay. So in Zeeman effect,
सर
yes,
इस चैप्टर से सर क्या क्या रिमेम्बर करना है
इस चैप्टर से रिमेम्बर
हमारे
क्या हाँ मैं बताता हूँ आपको। इस चैप्टर से स्पिन ऑर्बिट कपलिंग के साथ जेट का क्या रिलेशन है, वो सबसे ज्यादा इंपॉर्टेंट है। ठीक है। और आपका जो और कुछ याद करने का जरूरत नहीं है, जस्ट जो एक इंटरेक्टिंग हैमिल्टोनियन है वहां से जो स्प्लिटिंग कैसे करते हैं ना, जो जिस तरह की मैंने प्रॉब्लम करवाया आपको वही इंपॉर्टेंट है। एक चीज इंपॉर्टेंट है आपको याद करने का, जो स्पिन ऑर्बिट का कपलिंग के साथ जो जेड का प्रोपोर्शनलिटी है, जेड की पावर 4, वो बहुत इंपॉर्टेंट है। ठीक है। और प्रॉब्लम जिस तरह की मैंने आपको करवाया, आई थिंक यू एंजॉयड दिस टाइप ऑफ क्वेश्चन विल गेट एग्जैक्टली इन दैट एग्जाम। Little bit that constant will be modified, but same way you will get that question. In this Zeeman effect, okay, so it basically happens when you apply external magnetic field, right? External B. Okay, so there is a you have first Bohr model, then fine structure. So fine structure basically splitting of energy level, right? Now if you apply magnetic field, there will be further splitting of energy level, so we'll get many number of lines. Okay, so first in Bohr model you will get few line. Due to spin orbit coupling you will get more line. Due to application of external magnetic field you will get many more line. Okay, there is a further splitting of energy level due to the application of external magnetic field. So if you have to write that Hamiltonian, how it will look like? So first you will have unperturbed term, then you will have fine structured term, then you will have Zeeman term, right? So there is a three type of Zeeman effect. Everything told Atul sir, right? Shall I repeat it or I have to go?
It's
Shall
fine,
I?
sir.
Huh?
Sir,
Okay.
no need to repeat.
No need to repeat, right? But I must tell you that magnetic field created by due to that orbital motion of electron and spin motion of electron, that magnet or magnetic field. So when that electron is rotating or spinning, it will create magnetic field, right?
Yes.
And
Yes, sir.
that strength of magnetic field is very high. It is around 1 Tesla. You must remember that part, right? So now I'll go to so directly I'll go to that normal Zeeman effect. But before that, let me draw that experimental setup.
सर मतलब इंटरनल जो मैग्नेटिक फील्ड होता है वो 1 टेस्ला के
ऑन टेस्ला के अराउंड होता है, काफी स्ट्रॉन्ग होता है.
ओके
Now you have, suppose you have experimental setup. I'll draw. This is your south pole. This is your north pole. Here you have sample. Of course, it will have some total magnetic moment mu z. You have on detector, that is this side you are applying magnetic field. You have sample where? Here you have sample. In this place you have sample, and this is applied magnetic field, and this side you have on detector. This is D on. D on is perpendicular to applied magnetic field. So you have some sample, you are applying magnetic field, so that energy level will be splitted due to that part of Hamiltonian. So you have, this is your D1 detector that is perpendicular to applied magnetic field. You have another detector that is D2 that is parallel to applied magnetic field. But why I am saying that story, because when we look at emitted photon, so there will be transition among that line, so you will get some line photon here. So if you see this photon that is perpendicular to applied magnetic field, so you will get three types of component, that is pi, sigma plus, sigma minus. Three type of photon you will see, that is pi, sigma plus, sigma minus, and all are linearly polarized. So I'll tell you that what is pi component, sigma plus, sigma minus in later. But if you see that line perpendicular to applied magnetic field, or if you observe that emitted photon due to that transition, you will get three type of photon and all are linearly polarized. So this side you will have pi, sigma plus, sigma minus, all are linearly polarized. If you see that emitted photon parallel to applied magnetic field, then what you will notice here, if you see, then your pi component will be absent. This is experimental observation, okay? And you will see there will be sigma plus type of photon that is left circular polarized. You will have sigma minus type of photon that will be right circularly polarized. So in this direction, you will have three type of photon, all will be present, that will be perpendicular to applied magnetic field, and all are linearly polarized. But if you see parallel to applied magnetic field, in D2 detector, you will have pi type of photon will be absent, sigma plus type of photon will be present, that will be left circularly polarized, and sigma minus type of photon will also be present, that will be right circularly polarized. Okay. So this type of question are used to ask in GATE. Recently in 2022, they asked, and before that also they used to ask. Okay. So this you have to keep in mind.
सर
हाँ.
ये राइट सर्कुलर लेफ्ट सर्कुलर एक बार थोड़ा बता देंगे, पोलराइज बिल्कुल है।
अच्छा, आलोक सर ने नहीं बताया, देखो।
ओके सर, बता देते।
मैं थोड़ा सा बताता हूँ। जैसे आपका ये कोई EM वेव होता है ना, EM वेव होता है, तो उसका एक डायरेक्शन ऑफ प्रोपोगेशन होता है, जेड डायरेक्शन में ना। तो कॉस ओमेगा टी माइनस के जेड ऐसे होता है ना। तो एक्स एक्सिस, सपोज मान लो आपका टू कंपोनेंट है, एक आपका एक्स कंपोनेंट है, एक आपका EY कंपोनेंट है। मैं लिटिल बिट बोलता हूँ क्योंकि मेरा आगे बहुत जाना है, ठीक है। सपोज दिस इज योर एक्स एक्सिस, दिस इज योर Y axis, okay, and this is your Z axis, perpendicular to both. Okay, so you have EX component, you have UI component, you have EX component, UI component. Now first you will plot this component at omega t equals to 0. So you may get X component here, but there will be no Y component. Okay, after some time, after omega t equals to pi by 2, you check it. Okay, that time it may happen that your X is 0, X component is 0, Y component will be somewhere there. After some time pi, you will get X will be negative, Y will be 0, and after some time you will get X 0 but Y negative. Now your direction of propagation you will get from that concept omega t minus kz. If it is in positive direction, now you see your with time how it is varying, here, and your direction of propagation perpendicular to Z. Let us assume that will be provided you. Now you see this thing, which hand will give? Right hand. You see right hand curl is giving that change in that component, and thumb is providing you direction of propagation. Now if the opposite thing is happening, suppose you have at omega t equals to 0, you are getting X component, but at pi by 2 you are getting negative Y component. After some time you are getting here, after some time you are getting here. So basically this side you are happening. and your direction of propagation is perpendicular to this. So that time right hand side cannot give you that proper information, but left hand side clearly it will give you. So this is known as left circularly polarized light. So you have to plot that component at different time, then you have to use that right hand thumb rule and left hand thumb rule. Okay.
Okay.
A little bit, and later part if you have any curiosity after class you can ask me, I'll tell you. Okay, this thing is also important for your exam because they will provide you this will be left circular, right circular, so you have to check. Southern, did you get?
Yes, sir.
Okay, now now in normal Zeeman effect, so first will be normal Zeeman effect. So in normal Zeeman effect, magnetic field is weak, right? B is weak and S is how much? 0, right?
Yes.
This thing is discussed, Atul sir. So your Hamiltonian, part of Hamiltonian due to this magnetic field, that is, let us assume SJD, it will be how much? Mu B into ML, right?
Yes.
Is these things you know, right? These things due to the since your spin part is will be absent here, because normal Zeeman effect will only apply for spin 0. Okay, or spin 0 is known as singlet also, because multiplicity basically defined by 2s plus 1.
Yes, sir.
This is your multiplicity, right? Multiplicity. So when S is 0, you will get multiplicity on. This is known as, if multiplicity is on, this is known as singlet. So normal Zeeman effect basically apply to singlet. So this is your interacting Hamiltonian. So now let us assume this will give you some energy, that is, let us assume for the time being that H naught plus HFS, that Hamiltonian will provide you some energy, that is E naught. So now total energy will be how much? Total energy will be how much now?
E naught plus mu B PM.
So now your total energy will be okay. So total energy will be now for your system. So E will be how much now? E naught plus mu B, that is Bohr magneton. B is applied magnetic field, and ML. Now ML can vary. ML will be how much? Minus L2
Plus.
plus L2. Okay. So there will be many energy, right? Depending upon ML. Okay. Now you see, suppose you have on level, let us write that level on the two levels, you let us assume. This is your first level, that is on P1. On is multiplicity. Here on means this is multiplicity. So if this is basically represent 2s plus 1. So 2s plus 1 value is here on. So this is known as singlet. And that subscript basically J. So let me define term. Spectroscopic term, that is basically denoted by 2s plus 1 L, 2s plus 1 L J. So you see 2s plus 1 value is here on, it means s equals to 0. L is how much here? On. So
1, sir.
P, and here J is 1. Okay.
Oh,
So and this let us assume this is your on D2 state. So and also let us define this energy is E1 and this energy is E2. Okay, that separation E2 minus E1, let us assume this is your H nu naught. Now under the application of weak magnetic field. So this is, you see, spin 0. This state is spin 0, and I told you for that normal Zeeman effect only applicable for spin 0, and this term clearly see, this term is here spin 0 because this is a singlet. Same is true here also, spin 0, this is singlet. So after the application of weak magnetic field, how much will be the energy, that energy, how many energy level will be here? Can you tell me?
Sir, that is 2D, right? So 5 will be there. 2s plus 1.
Good. And here how many energy level you will get?
3, sir.
3.
Good. So you see this energy will be how much?
That's 2.
So it will be E2 plus 2 mu BB, right?
Yes, sir.
Because for this case ml will be how much? Ml will be 2, right? So if ml will be 2, then energy is for this level is E2 plus 2 mu BB. Okay, and for this it will be E2 plus mu BB, and for here ml is how much? On. For this case it will become how much? It will be simply E2, right? Because here ml is how much? 0. Here it will be how much? E2 minus mu
Minus
B, and here E2, of course ml is how much? Minus 1 here. E2 minus 2 mu B, ml is minus 2 here. Okay, and here you will have E1 plus mu BB. Why I am writing this part is really important. Then you will have E1 here. You have E1 minus mu B, and this ml value here, it will be on 0. Okay, and minus 1. Okay, now we see this separation is how much?
Mu BB.
Mu BB. This separation is how much?
Mu BB.
Mu BB. Okay. Now that selection rule of transition is for singlet, singlet to singlet transition, that ml should be, can be 0 or plus minus 1. No, now let us apply that plus 1 first. So plus 1 means when there is a transition from 2 to 1, right? When
Yes,
there
sir.
is a transition from 1 to 0, when there is a transition from 0 to minus 1. So you are getting 3 line. Now can you tell me how much will be the energy for this line? So it will be how much? E2 plus 2 mu B minus E1 minus mu B.
Mu BB.
Mu BB. So how much it will be? E2 minus E1 plus mu BB.
Sir.
E2 minus E1 plus mu BB. Can you tell me for this transition how much will be the energy of this photon? So E2 plus mu BB minus E1. So again you are getting same energy for this transition also. Similarly, same energy you will get for this transition. So E2, then E2 minus E1 minus plus mu BB. So all these 3 photon is basically giving you same energy. So how many line will you observe? Only
3.
only one line you will observe.
Only
Because
one,
all these photons have same energy. It means you can see from 3 transition only one line will be observed because they have same energy. Now what about ml? So this corresponds to, you can write here also that delta ml. So there here delta ml. Okay, so delta ml here I have applied plus 1. Now let us apply 0 delta ml. So when 1 to 1 transition, 0 to 0 transition, and minus 1 to 1 transition. So 1 to 1, 0 to 0, then you have minus 1 to minus 1. Now can you tell me the energy?
E naught, sir.
E naught.
E naught, right? Or you can say
Yes, sir.
H naught, right? So this will give you, and all will have same energy, right? So for ml, delta ml corresponds to 0, will give you 3 transition, but all will have identical energy. So for this also you will get only one line. So this corresponds to delta ml, that is 0. Now what about delta ml minus 1? So when you will get this line, when there is a transition from 0 to on, right, minus 1 to 0 and minus 2 to minus 1. Here how much energy you will get? How much energy you will get? So we will get E2 minus E1 minus mu VV, right?
Yes.
Okay. So here I have applied delta ml equals to minus 1. So basically there are 9 transition, but out of this only 3 lines will be observed. So that in spectrum, let us assume along this side you have nu bar. Nu bar means wave number that is in semi inverse. So we'll see sigma plus means delta ml corresponds to plus 1, that is known as sigma plus component. Okay, then you will have pi component that corresponds to delta ml 0, and you have sigma minus component that corresponds to delta ml minus 1. So you can see there are only 3 lines are observed. Now can you tell me that separation between 2 lines in terms of wavelength or in terms of energy? Can you tell me separation, this separation?
So nu BB.
Exactly. So there are separation in energy, that will be how much? Simply mu b p. And this is very important for your exam purpose. Very important these things for your exam purpose. What will be the separation between 2 components of normal Zeeman line? So what they will ask? They will not ask in terms of energy. They may ask what will be the frequency shift between 2 components. What will be a separation between 2 components in terms of wavelength? Okay, or they will provide you that separation between wavelength, or I'm writing that expression. So now what you can write? So in place of energy, you can write hc by lambda, right? In place of energy, you can write hc by lambda. That will be simply mu b. Okay. Now I think one thing I forgot to mention. So whenever you see there is a singlet to singlet transition, and if they ask you how many line you will observe, or how many component you will get, so whenever there is a singlet to singlet transition, there will always be only 3 line will be observed. Okay, whatever d l j value are there, but whenever there is a singlet to singlet means this 2s plus 1 value is on. So if there is a singlet to singlet transition, you will only get 3 lines. Please keep in mind. Okay, कुछ फॉर्मूला लगाने का जरूरत नहीं है, ठीक है? तो यहाँ पे डेल्टा ई के जगह पे एच सी बाई लैम्डा सब्स्टिट्यूट कर दिया, और दैट शुड बी इक्वल्स टू म्यू बी बी. नाउ कैन वी राइट लाइक दिस, माइनस एच सी बाई लैम्डा स्क्वायर डेल्टा लैम्डा equals to mu BB, right? So from here you can clearly see that delta lambda equals to mu BB into lambda square divided by HC. I am taking mod only, okay, because I am calculating delta lambda. So this formula is important because they will give you that lambda corresponds to this transition. They will provide you lambda. They will provide you that magnetic field for Zeeman effect, and they will ask you what will be the separation between 2 components. Okay, or they may ask you, they may provide you that delta lambda value, that lambda corresponds to this, and they will ask you minimum, how much minimum field is needed to get that Zeeman effect. So this is the main formula. Okay, I'll use this. You may see in net 3-4 times. I'll come to that problem also. 3-4 times came in exam, also in GATE. Okay, so it's a very important formula. Is this clear? So whenever there is a singlet to singlet transition, you will get only 3 components, and that is the separation between 2 successive components. Is this clear? Is this clear to all?
Yes, sir.
Okay.
Yes.
What is the time now?
6:30.
6:30 सर
6:30. ठीक है, थोड़ा 10 मिनट और करके फिर ब्रेक लेंगे, है ना? फिर आप लोगों को शॉर्टकट सिखाएंगे एक, है ना? तो फिर कुछ करने का जरूरत नहीं। चलो इसको इरेज कर सकते हैं।
Yes, sir.
सर
यस
सर 1D to 5 में स्प्लिट हो रहा है
on D2, yes, there will be 5 because you see, because this is J I am writing na, so that is basically containing here L part because S is 0, right? And I told you that ML can take value from minus L to plus L. So
Yes,
there will
sir.
be that is that also used to ask. Suppose they will provide you this kind of thing also used to ask. Suppose they will provide you this state. So how many degeneracy of this state? So how will apply? So degeneracy will be how much? 2J plus 1. So if you apply 2 into 3 by 2 plus 1, it will be 4. So whatever, if you have this J value under the action of magnetic field, there will be splitting. That splitting will be how much? 2J plus 1. So there in that case on D2. So J was how much? 2. So 2 into 2 plus 1. So it will be 5. So there will be 5 line. Is this clear now?
Yes, sir. Yes, sir.
Now I'll come to that anomalous Zeeman effect. Okay, anomalous Zeeman effect. So in that case, part of Hamiltonian is how much? A is ZD. That will be how much? Z mu V, then B
Yes.
P mj, right? Now you have S non equals to 0 for this case. S non equals to 0 and B is weak. Applied magnetic field is weak, but S is non equals to 0. And G here is what basically? Landesi factor. Landesi factor, right? For spin S, it will be Z. It will be 2. But in general, this is known as Landesi factor, right? This is very important in spectroscopy because this basically defines, Landesi factor basically defines the split amount of splitting between two successive sublevels. Okay, and this is the form of this is anyone 1 plus J into J plus 1 plus S into S plus 1 minus L into L plus 1 divided by 2J into J plus 1. Many times in question CSIR also, they used to ask what will be the value of G factor. They will provide you J, S and L. Okay. And in 2018 recently, they provide you that value of J. Okay, that is 2, S is 1, L is 1. So how much will be the value of G factor? Okay. So it's a simple online calculation and that was 5 marks question. So this is basically here the G is basically Landesi factor. Okay. Now I'll come to that sodium D on D2 line and we will understand that how the transition, what is the role of that G factor. Okay. Now we'll come. So in normal state, now we'll study that sodium D on and D2 line, and that basically belongs to anomalous Zeeman effect. Okay. So if you see in ground state of sodium, the state is how much? What is the state? Ground state? Anyone? So,
What, sir?
ground state of sodium. What is the ground state of sodium? let us denote this is your, I'm starting now only sodium. So if you see that sodium,
The
its
3s.
its ground state is basically S, 2s half. Its ground state basically is 2s half. So under the action of magnetic field, it will split into two parts. That is 2s, sorry, it will split into two parts. But before that, let me define few factors. I'll define few factors. So first I'll define that state 2s half, then 2p half, then 2p 3/2. Here I'll define that degeneracy. Okay, then G value. Okay, then Mj value. Okay, then Gmj. Here the splitting, amount of splitting of any energy level. In earlier case, if you see normal cases, amount of splitting basically defined by only ml. Now that amount of splitting is not defined by mj, but there is a factor that is g factor. That's why you have to study that g factor also. Suppose you have state 2s half. 2s half, this is your state. So what will be the degeneracy of the state? Can you anyone?
The 2.
2, good. What will be the g value or g factor? So for s, here the j value is how much? Half.
Half.
Half. So 1 plus 3/4. S is how much? Here 2s plus 1 is
Half.
2. Half. So 3/4. L is how much?
0.
0. So how much will be the g now? 1 plus 3/4, then 3/4.
2 हो गया.
Good. Then you have 2 into 3/4. So you can see 1 plus 1, it will be 2. Okay. So like that you can calculate. So this is your 2. What will be the mj? Mj will be plus minus half. Right? Mj will be how much?
Okay.
Plus minus half. And Gmj will be how much now? Plus minus
Plus minus 1.
minus 1. For this state, if you calculate for 2p half, G degeneracy again will be 2, 2j plus 1. G will be how much? You calculate it from this formula. You can calculate, right? Because here S is half, L is 1, J is half. So you can, if you calculate from this factor from this formula, you will get 2/3. Okay, and again mj is how much? Plus minus half. So that's gmj will be how much? Plus minus 1/3. And for this case, degeneracy is 4, 2j plus 1. If you calculate g factor again by using same formula, you will get 4/3. And this will be mj will be how much? Either it can be plus minus 3/2 or it can be plus minus half, because mj can be 3/2, half, minus half, minus 3/2. So 3/2 minus 3/2 I have written in single form, and it will be like that. So this will give you how much? This will give you
2.
gmj will be plus minus 2, and this will give you how much?
1/6.
Plus minus 2/3. 2/3, right?
Okay,
Or-
yes, sir.
Okay. So this is the state. Okay. Now I'll come to that sodium D1D2 line, because sodium ground state of sodium is basically this. First excited state this, then second excited state this. Okay. I'll come to this sodium D1D2 line.
सर ये कैसे है सर ग्राउंड स्टेट वेस्ट का?
हाँ, एक्चुअली ग्राउंड स्टेट मैं थोड़ा एक्चुअली एलिस कपलिंग में बताना चाह रहा था, जैसा आपका सोडियम है ना, इसका कॉन्फ़िगरेशन करोगे 1s2, 2s2, 2p6, ठीक है, 3s1, ठीक है। तो एलिस कपलिंग का पार्ट है, कल डिस्कस करेंगे थोड़ा सा। आई एम रियली सॉरी कि यहाँ पे आपको डिस्टर्ब कर रहा हूँ। तो फिर आपका लास्ट इलेक्ट्रॉन क्या है? लास्ट इलेक्ट्रॉन क्या है? 3s1।
3s1 yes
ओके, तो यहाँ पे एल कितना है? 0 है।
0
एस कितना है? हाफ।
हाफ।
जे कितना हो जाएगा? हाफ हो जाएगा, है ना?
yes
तो टर्म को कैसे डिफाइन करोगे? 2s plus 1 एल जे। तो 2s plus 1 की जगह पे क्या रखोगे? 2 हो गया, s है ना, और j कितना है? हाफ है। ठीक है, कल डिस्कस करेंगे इसको, क्योंकि आज एक्चुअली सर ने पढ़ा दिया इसलिए मैं इसको एक्सटेंड कर रहा हूँ, नहीं तो मैं पहले एलिस कपलिंग पढ़ाता आपको, कल पढ़ाएंगे इसी, ठीक है।
Okay, sir.
Okay, so this is all about your that splitting everything. Why I am calculating GMJ? Because these things here I need this part, because these things actually telling you that amount of splitting. I'll come to that beyond D2 line, that time it will be understandable.
Sir, ये right side drop मत.
हाँ?
Right side drop मत.
हाँ ठीक। Okay. Now ground state of sodium. Now we'll discuss sodium D1 and D2 line. So if you see the ground state, it will be 2s half. Then you have next state is that will be 2p half. Then next state will be 2p 3/2. Okay. Let us define this is your ion state, this is your E2 state, this is your E3 state. So under the action of magnetic field, what will happen? It will split into two parts, right? Now how much will be the energy of this level? Anyone? How much will be the energy of this level?
Plus mu BV and minus
Good.
mu BV.
Good. So it will be ion plus mu b, because if you see that interaction term, that is GMJ mu BV, and for 2s half that GMJ is how much? Plus minus mu BV. So for upper state it will be added, for lower state it will be subtracted. Okay. Now here also you will have two splitting, that corresponds to. Now what will be the energy of this state now?
Or E2 minus 1/3 mu BV.
So in upper state, good. So it will be E2 plus mu b by 3, and for this state it will be E2 minus mu b by 3. Okay. Here you can mention also, here mj is how much? Mj is how much here? Minus half, right?
Yes,
Here
sir.
plus half.
Plus. Yes,
Here minus half.
सब +1 है सर वहाँ पे.
हाँ.
प्लस ये नीचे वाले +1 -1 +1 है सर.
कौन सा ये वाला?
ये S हाफ में
हाँ ये
-1 एंड +1.
नहीं माइनस हाफ है ना, जे का वैल्यू कितना है? प्लस हाफ ना,
हाफ.
तो mj कैन बी प्लस हाफ माइनस हाफ.
अच्छा MJ की वैल्यू खाली. ओके सर. ओके.
This will be 3. Okay, let us understand first Dion line. So when there is a transition from 2p half to 2s half, and before application of magnetic field, you will get only one line that corresponds to E2 minus E1. Okay. Here mj is half. Now under the application of magnetic field, you will get this kind of splitting. Now the selection rule for this transition is what? Delta mj equals to how much? 0 plus minus 1. But 0 to 0 is not allowed if delta j equals to 0. If delta j equals to 0, then 0 to 0 is not allowed. If there is mj equals to 0, mj equals to 0 here, 0 to 0 is not allowed if delta j is 0. Okay, but there is no delta mj 0 here, so this rule will not be applicable here. Okay, now can you apply this rule? So let me write first.
सर E3/2 के लिए नहीं लिखेंगे सर?
अभी करेंगे, पहले स्पेस नहीं.
ओके सर.
अब बताओ यहाँ पे कि क्या होगा? डेल्टा mj प्लस लगाओ तो कहाँ से कहाँ हो सकता है? एक तो आपका प्लस हाफ से माइनस हाफ में हो सकता है ना? इसका एनर्जी कितना होगा?
So
E2
2 nu BB by 3.
E2 minus E1 plus 4 by 3, right?
Okay, yes sir, yes sir.
4 by 3 mu b 3. Okay. And let us define this E2 minus E1. Let us define this number. Then it will be simple. H nu naught. Okay. So this will basically how much? H nu naught. Now there will be no delta mj plus minus 1. Only one transition is possible for that. Okay. This corresponds to delta mj plus 1. Okay. Now if we apply delta mj equals to 0, so 1 to half is possible, and minus half to minus half possible. There will be two line. There will be two line corresponds to delta mj 0, or you can say this is corresponds to sigma plus this corresponds to pi.
तो माइनस हाफ से प्लस हाफ नहीं होगी सर?
Minus half से
-1 तो प्लस हाफ.
हाँ, that delta mj will be minus 1 na. So first I have applied
Yes.
here delta mj plus 1, then delta mj 0. Plus 1 corresponds to sigma plus 0 corresponds to pi. Now I'll apply delta mj correspond. Now one thing, can you tell me, will there be same energy for this delta mj? Two lines are there. Will there be energy same here? So you see here delta mj equals to 0. So E2 plus mu b by 3, and here energy is how much? E1 plus mu b, right? So if you subtract, you will get for this line you will get E2 minus E1 minus 2 by 3 mu b for this line. You can check E2 minus E1 mu b by 3 minus mu b. So it will give you E2 minus E1 minus 2 by 3 mu b. But for this line, can you check energy? So it will give you E2 minus E1 minus mu b by 3 plus mu b. So it will basically give you E2 minus E1 plus 2 by 3 mu b. So these two lines will not have same energy. So earlier it will have same energy. Why? Because if you see that splitting, here splitting is how much? That splitting is how much? Mu b by 3. But here splitting is how much? That splitting mu b. So in anomalous case, amount of splitting is not same for all term. For higher state, amount of splitting is different. For lower state, amount of splitting is different. So that's why whatever transition you will get, mostly they will have different energy. So for you will get two line that corresponds to delta mj 0, and there is only one transition is possible that corresponds to delta mj equals to minus 1. That will be what? Minus half to plus half, right? So you will get 4 line, 4 will have different energy. So if you draw that spectrum, how it will look like? You have sigma plus here, you have 2 line for pi, and you have sigma minus here. Is it clear? Is this clear?
Yes, sir.
Now can you
Yes, sir.
draw for 2p3 by 2 to 2s half? So this is known as basically
सर
d1.
सर पाई के लिए दो लाइन के सही सर?
पाई के लिए देखो ना डेल्टा mj 0. So half to half
Yes
transition,
sir.
half to half
Yes sir.
delta mj 0, and you have minus half
Yes,
to
sir.
minus half. Minus half to minus half. Minus half delta
Sir,
mj. Yes.
ठीक है सर.
हाँ, एनर्जी भी देखो इसका डिफरेंट है. इसका एनर्जी
सर
देखो.
एनर्जी डिफरेंट.
हाँ.
और अगर सर सेम एनर्जी होती तो मतलब कि
सेम
मतलब कि एक ही लाइन होती ना?
एक ही लाइन होती.
एक ही लाइन होती.
हाँ.
Okay.
But in anomalous case, mostly you will get different energy. And you see, if they will give you complicated system, that time it will be very difficult to count number of line. That's why I'll give you shortcut. No need to remember anything. Okay, is this things clear? Okay.
Yes, sir.
So this is D1 line. Okay, this is D1 line. Now I'll draw sodium D2 line here. Again, that will be same ground state. Okay. So this is all about your 2s half. E1 2s half. Okay, and you have 2p 3y2 here. Okay, and this was your E3 state. So it will be split into how many state sub level?
The 4.
4. Good. Okay, mj value is how much here? 3/2, right? Then half minus half minus 3/2. Here half minus half. Now let me check first delta mj plus 1. How many lines you'll get? So 3/2 to 1/2, right? Then 1/2 to minus half. Delta mj 0. So this is basically sigma plus. I'm giving you homework. You calculate the energy of these two lines. So you can clearly calculate, right? Like earlier, I have written that energy. You can write there also that energy. So if you see, if you calculate that energy, they will have different energy. Same as this. Whatever I written in terms of energy, you write it and you apply that selection rule, you will get. And for delta mj 0, so half to half is possible, minus half to minus half possible. So that will basically give you pi. Okay, and then you have delta mj minus 1. So where it will be? So minus half to plus half, right? Minus 3/2 to minus half. So that will give you sigma minus. So all 6 lines will have different energy. All 6 lines will have different energy. So if you see that spectrum, it will look like this is sigma plus, this pi, then sigma minus. ये कैलकुलेट कर सकते हो आप लोग एनर्जी ना, जैसे यहाँ पे मैंने लिखा हूँ वैसे कैलकुलेट करो.
Yes, sir.
So we will get 6 lines there. Now 5 मिनट ब्रेक होगा, फिर हम प्रॉब्लम करेंगे. शॉर्टकट बताएंगे, फिर प्रॉब्लम करेंगे. बहुत इंपॉर्टेंट होगा फिर, है ना. 5 मिनट ब्रेक के बाद स्टार्ट करते हैं.
No army! That's right. This small island nation of Grenada in the Caribbean decided to let go of their army and instead use them.
सब चिपका के रखे हैं, सब चिपका के रखे हैं.
एक सीट के लिए लड़ाई लड़ी थी. वो पहला ऐसा इंसान था जो मेरी पसंद का ख्याल रखते हुए मेरे घर पे पानी पूरी भेजता था. वो पहला ऐसा इंसान था जो मेरे होठों से पहले मेरे माथे चूमता था. मैं उसे कैसे भूल सकती हूँ. वो पहला ऐसा इंसान था जिसने मुझे मजबूर कर दिया था ये सोचने पर कि खुद की खुशी का ख्याल रखना बुरा नहीं है. पहला ऐसा
आखिर जिंदगी ने भी आज छीन लिया मुझसे. कहाँ है वो शख्स? आखिर